Hello guys, myself Sahil, studying in SVC College of Engineering, Bangalore. Subject Mathematics. In this video, we can discuss about partial orders and hash diagrams. Introduction. In descriptive mathematics, a partial ordering or partial order is a binary relation on a set that is reflexive, antisymmetric and transitive. A set with a partial ordering is called a partially ordered set or poset, unlike total orders where every pair of elements is comparable. Partial orders allow for incomparable pairs. Key concepts: reflexivity. Every element is related to itself. A is less than or equal to A. Antisymmetric: if A is related to B and B is related to A, then A is equal to B. That is, A less than or equal to B and B less than or equal to A. That implies A is equal to B. Transitivity: if A is related to B and B is related to C, then A is related to C. That is, A less than or equal to B and B less than or equal to C implies A less than or equal to C. Examples: less than or equal to on the set of real numbers. This is common example of a partial order subset relation on the power set of a set. For example, on the power set of 1, 2, 3 and 1 is a subset of 1, 2 is a partial order divides relation on the natural numbers. For example, 2 divides 4 and 4 divides 8 are the examples of partial orders. Partial order relations. A relation R on a set A is a partial order relation. If R is a reflexive, R is a antisymmetric and R is a transitive, we use less than or equal to as the generic symbol for a partial order relation. Hash diagram. A hash diagram is a graphical representation of a partially ordered set or poset where the elements are shown as points and connections of edges between them indicates the covering relationship, meaning one element is directly above another in the order. It provides a visual way to understand the relationship within a partial order without showing all the transitive connections. A visual representation of a poset showing the covering relationship between the elements. Partially ordered set or poset, a set with a partial order relation, meaning not all elements are comparable. For example, you cannot always say one is greater than or less than another. Covering: in a hash diagram, an edge connects two elements if one directly covers the other, meaning there are no other elements between them in the ordering. Vertices: each element of the poset is represented by a point or vertex in the diagram. Edges: edges connect vertices to show the covering relationship. Transitive closure: hash diagram only show direct covering relationship, not transitive relationship. For example, if A covers B and B covers C, it does not explicitly show A covering C. How to create a hash diagram? Represent element. Draw a point for each element in the poset. Second, identify cover relations. Determine which element directly covers others, meaning there are no elements in between them in the partial order. Draw edges. Connect the points with lines to show the covering relations. Placement: usually elements are placed higher in the diagram if they covers other. For example, consider the set 1, 2, 3, 4, 5 with the partial order defined by divides. For example, 2 divides 4. A hash diagram would show I is the root element as it divides all other 2 covers 4 and 5, 3 divide covers 6. Benefits of using hash diagrams: Visualization. They provide a clear visual representation of partial order. Clarity. They are simpler than listening out all the relationship and are easy to understand. Understanding. They help in understanding the structure and properties of the partial order. Unique representation. A hashed diagram uniquely determines the partial order. Conclusion. In descriptive mathematics, partial ordering and hash diagrams are fundamental concepts for representing relationship between elements within a set. A partial ordering defines a hierarchy, and hash diagrams visually represent this hierarchy, simplifying the graph of the relation of removing redundant edges. This conclusion emphasizes the importance of hash diagram in visualizing and understanding partial ordering, making them a valuable tool for descriptive mathematics and computer science applications. Thank you.